A is one mechanism, B is another mechanism, and C is another mechanism. Now, any enzyme you see ending with ogen or starting with pro is a zymogen. Fibrin is involved in blood clotting, right? Good. If fibrin is in the active form and it's in your blood, what do you think will happen? Your blood will just be clotting, right? So let's look up. So we'll be looking at zymogen activation. Zymogen activation. Now, the very first thing you have to notice, if you don't call it zymogen, the other name you can call it is what? Proenzyme. And simply, zymogens or proenzymes are inactive enzymes. Enzymes, though they are in the body, but they are not active yet. Those inactive enzymes are called what? Proenzymes or what? Zymogens. So some enzymes are in the body, but at that point, they are not active yet. Let's take, for example, if you have something like digestive enzymes. If you have the digestive enzymes, or let me use, which of the enzymes, give me one enzyme that's involved in blood clotting. Fibrin. Fibrin is involved in blood clotting, right? Now just imagine, fibrin involved in blood clotting is active as you're sitting down here. The fibrin is active. What do you think will happen? So fibrin, let's imagine, fibrin is involved in blood clotting, right? Good. If fibrin is in the active form and it's in your blood, what do you think will happen? Your blood will just be clotting, right? So it is secreted in the inactive form called fibrinogen. The inactive form. So to prevent the blood clotting, so it is only during injury, if I have an injury here, that fibrinogen will now be converted to the active form fibrin, so I can carry out its function. So you see why enzymes exist in the inactive state, right? So they are only activated when their functions are needed. So from what I've said so far, I said if you don't call it zymogen, you call it what? Proenzyme. And are they active enzymes or inactive enzymes? Inactive enzymes. So once you hear proenzyme, what should come to your mind first is inactive enzyme. Now if you look at the spelling of zymogen and proenzyme, zymogen ends with what? Ogen, right? Proenzyme starts with what? Now, any enzyme you see ending with ogen or starting with pro is a zymogen. It's an inactive enzyme. Do you get that? Any enzyme starting with ogen, ending with ogen or starting with pro is what? Inactive enzyme. Let's look at some examples of zymogen, having known the meaning of zymogen now. The first one here is what? Now, examples of zymogen. Zymogens are always ending with ogen or starting with what? Pro. Now, an example, trypsinogen. So since you're seeing ogen here, you should know it's an inactive enzyme, right? Good. So, trypsinogen, if it's activated, we have what? Trypsin. Chymotrypsinogen, if it's activated, chymotrypsin. Pepsinogen, if it's activated, pepsin. So these are inactive forms and these are the active forms. Do you understand now? So write that down. Now let's look at the mechanisms of zymogen activation. The mechanisms of zymogen activation. We've already seen that if you don't call it zymogen, you call it what? Proenzyme. And we've seen that proenzymes are inactive forms of enzymes, right? And for it to be activated, there must be a biochemical change, is it not? Now, the mechanisms of zymogen activation, we have three main mechanisms of zymogen activation. And the three main mechanisms can be represented with this. A is one mechanism, B is another mechanism, and C is another mechanism. But before we look at the mechanisms one after the other, let's look at the active enzyme. An enzyme is like this. Let's take this to represent an enzyme. This site here represents the active site of an enzyme, right? Good. Every enzyme has their active site. Enzymes, when the substrate binds, catalysis can take place, right? The active site is where the substrate binds, right? Then there is a catalytic subunit where catalysis now take place as the substrate binds to this. Is it not? Now, this is the active enzyme. Now look at this shape. The circle is used to represent the what? Substrate binding side, right? While the triangle is used to represent the what? The catalytic apparatus. Let's look at the first mechanism. This is a zymogen, meaning this is an inactive enzyme, right? Now, what do you notice? What's the shape of the substrate binding side here? Rectangle, right? But the active enzyme, square or rectangle? Okay, let's make it a square. But even if it's a rectangle, you have no problem. So, here is square and here is what? But the catalytic apparatus, are they the same? Yes. So you see that the problem with this zymogen here is what? Substrate binding side, right? So if we want to make this enzyme, this zymogen, an active enzyme, what do you think we'll do? We'll change the shape of the what? Of the substrate binding side, right? So one mechanism of zymogen activation is conformational change. I'll give you the note. It's conformational change in the structure of the substrate binding site. So if the structure of the substrate binding site changes, then the zymogen becomes active. So some zymogens, some inactive enzymes, the shape of the substrate binding site is different from, for a substrate to bind to the enzyme, according to the lock and key model, the substrate must have the same shape as the active site of the enzyme, right? Is it not? It's just like your padlock and your key. If you put a wrong key in a padlock, will it open? No, right? Now, the substrate is like that key and the lock is like that enzyme. The enzyme have an active site like this, has a preformed shape. The substrate, if this substrate does not have the same shape as this active site, catalysis cannot take place. Is it not? So some enzymes, some inactive enzymes, some proenzymes, they have a different shape of the substrate binding site, different from that of the substrate. So even when the substrate comes, they cannot even bind because that's not the shape. Then if you want to activate that enzyme, there will be a biochemical change, changing the conformation, the shape of this substrate binding site to the ring shape, so that when the substrate binds, it can bind, right? And catalysis can take place. So one mechanism of zymogen activation here is change in the shape of the what? Substrate binding site. Is it not? Good. The second mechanism, the substrate binding site, is it the same? It's the same, right? The catalytic apparatus, are they the same? So yeah, the substrate can actually bind, right? But even when the substrate binds to the enzyme, catalysis cannot take place because the catalytic apparatus, they have different shapes here, right? So to activate this zymogen, what do you think? Change the shape of the what? Of the catalytic apparatus in the zymogen. So if the shape of the catalytic apparatus is changed here, then catalysis can take place. You've activated the enzyme. Do you get that? Yes. In the third mechanism, what do you notice? The shape of the substrate binding site, they are the same, right? Yes. The catalytic apparatus, they are also the same. Yes. But there is an occlusion, there is something that is covering it. Do you get? That is what we are representing with this line. There is an occlusion, something that is covering it. So for us to activate this zymogen, what do? Remove the blanket, right? Remove the occlusion. So the three mechanisms of activation of zymogen, one is changing the shape of the substrate binding site, right? Two, changing the shape of the what? Catalytic apparatus. And three, removing occlusion. Do you understand? If you are asked to draw this in exam, please, if you are asked to write, because it's always coming, write on the three mechanisms of zymogen activation. If you don't draw this, you've lost like half of the marks. So ensure you draw this. Then you now say, from the diagram above, you start to explain.